Friends, welcome to my YouTube channel Make Maharashtra. We have seen the open and cross belt drive numerical and their design procedure. Now we'll see the design procedure for V belt drive. So what is the difference? Basically the difference is that V belt drive is having groove, and that we need to consider, and the structure is like this V belt drive and having some length, suppose A, and this width is B and height is suppose C. So the first step is to calculate the cross section of V belt drive. So how I can calculate this cross section? See, area is equal to, cross section area is equal to half of A plus B into C. Did you get it? Are you getting? Half of A plus B, this side plus this side, into height. So that will be the area. So I have written here. So this is one example I quoted here. So this will be the cross section area we can calculate for V belt. First thing. Now second is same as like a previous one, that is open belt drive. Pitch line velocity pi dn by 60. Smaller d we need to consider because smaller d we are having more RPM. Then centrifugal tension mv square. Now here in V belt drive, mass is converted into density to volume, but while converting this, so we cannot take the thickness and width, because that thickness and width is V type of belt is there, so it does not have that, it has having area. So we'll have to consider mass is equal to rho A into L, density into area of that respective V belt V shape and length of that V belt with respect to velocity. Keep in mind, in case of the V belt drive, again I will repeat, m in Tc is equal to m square, but in case of the V belt drive it is rho A L and Vb square, correct? A can be defined B into T, no problem. Clear? Next will be the diameter. We know the speed ratio, bigger divided by smaller is equal to smaller divided by bigger in terms of the diameter and RPM. Now angle of contact alpha is equal to d minus. So always remember, V belt is always open belt drive. Why? If it is not open belt drive, if it arranged in cross belt drive, there will be the choke up between the belt, so there will not be the movement in between the two pulleys, correct? That's why V belt is always open belt drive. Therefore we have used the equation of the open belt drive as it is, that is in minus. So therefore angle of contact theta is equal to pi minus 2 alpha. So this is the fifth one. Sixth one, sixth is T1 by T2 is equal to e raised to mu theta. Generally we have to take, but here we have to take e raised to mu theta divided by sine of phi. So phi is nothing but what? It is a groove angle. What is, which groove? See, this is V belt. Now this will be the dotted line. So this phi is called as a groove angle. So that we need to consider. That's why here e raised to mu theta divided by sine phi. So keep in mind this two additions, that is T1 by T2 e raised to mu theta and this one Tc. Clear? Now here we will get the limiting tension, and through which we can calculate T1 and T2. Then belt tension T1 is total tension is equal to T1 plus Tc, that we know. Next formula is related to the ratio. They will give you the ratio, accordingly we need to compare with respect to this e raised to mu theta. Then power transmission P is equal to T1 minus T2 into velocity, that we know. Now here is additional term is number of belts required, because V-shaped belt is not made by the single made in single manufacturing process. So we need to join it and then it can be made. So therefore the number of belts are required for joining in case of the V belt drive. So number of belts we can calculate is total power transmitted by the belt and power transmitting capacity of that respective belt, correct? So two belts are there, its capacity is different and total power transmission expectation is different. So by dividing these two terms, we'll get the number of belts are required. And of course length of belt is again same as that of open type of belt, as I told you. So these are the some design procedure which we need to follow for solving the V belt drive. Again I will repeat the things. Velocity we can calculate for the V belt drive is, sorry, V belt drive, V cross section we need to take the area, that is half of bottom side plus top side into height. Velocity, pitch line velocity, then centrifugal tension mv square changes is rho a l, then speed ratio, angle of contact alpha we need to calculate and kept as a open belt drive, T1 by T2, just add the sine of phi because it is groove angle, and T is equal to T1 plus TC, correct. So therefore this ratio will be given, and this ratio and this value will get the T1 and T2 tension on tight side as well as the slack side value. Then power is equal to T1 minus T2 into velocity, and then new term is number of belts, because 2 belts, 3 belts, 4 belts can be used for the V belt drive. So that will be the ratio of power total transmitted divided by actual power transmitted by each belt, and length of the belt we can calculate as like a open belt drive. Clear? So just write down the formulation from your side stepwise. I hope you understood this session. Thank you.